Scientists have made a jaw-dropping discovery at the very heart of one of the universe's most enigmatic and feared phenomena, the black hole. This incredible finding is both awe-inspiring and terrifying, as it challenges long-standing theories about the cosmos and shakes the very foundations of modern astrophysics. What lies deep within these cosmic monsters may be far stranger than we ever imagined. Brace yourself, because today, we are about to pull back the curtain on the mysterious and hidden core of a black hole. Welcome to Wave's Discovery. If you're passionate about unraveling the secrets of the universe and exploring the wonders of space, make sure to hit that subscribe button, like this video, share it with fellow space enthusiasts, and turn on notifications, so you never miss an update from us. Black holes are among the most fascinating and extreme objects in existence. First theorized by the legendary Albert Einstein through his groundbreaking work on general relativity, black holes defy our normal understanding of space, time, and gravity. According to Einstein's theory, gravity is not a simple force that pulls objects together, as we might intuitively think. Instead, it is the result of how mass and energy warp the very fabric of space and time itself. Picture space-time as a stretched rubber sheet. The heavier an object, the deeper the dent it makes in this sheet. Now, imagine something so massive, so dense, that it creates a bottomless pit in this fabric. That's a black hole. Black holes are born from the gravitational collapse of massive stars and are regions where mass and energy are crammed into an unimaginably tiny space. The resulting gravitational field is so intense that even light, the fastest traveler in the universe, cannot escape. This leads us to the famous event horizon, a mysterious, invisible boundary that surrounds the black hole. It's not a physical surface, but rather a point of no return. Once anything, be it gas, dust, stars or even light itself, crosses this boundary, it's lost forever, trapped in the black hole's inescapable grip. To put this into perspective, imagine holding a flashlight. The beam travels at approximately 300,000 kilometers per second, the fastest speed allowed in the universe. But near a black hole's event horizon, the gravitational pull is so overwhelming that even light's staggering speed isn't fast enough to break free. At the very core of a black hole lies something even more mysterious, the singularity. This is where all of the black hole's mass is crushed into a single, infinitely small point with infinite density and curvature. At this point, the known laws of physics break down completely. Gravity and spacetime reach such extremes that our current understanding of reality no longer applies. It's as if the universe's rulebook stops working. Scientists and physicists have long been baffled by the singularity. What really happens inside it? Is there another universe? Could it be a gateway to unknown dimensions? Or does it simply mark the end of space and time? These are questions that continue to drive the imagination of cosmologists. To grasp the formation of black holes, we must look back at the life cycle of massive stars. These stars are colossal nuclear fusion reactors, fusing hydrogen into helium in their cores and releasing vast amounts of energy in the process. As long as there's enough hydrogen fuel, the star maintains a delicate balance between outward pressure from nuclear fusion and the inward pull of gravity. But when the hydrogen runs out, the star begins fusing heavier elements like helium, carbon, and oxygen. Each new fusion stage releases less energy than the last, forcing the star to burn faster and hotter. Eventually, the core can no longer sustain fusion, and gravity wins. The star collapses inward, triggering a cataclysmic supernova explosion. What remains after this violent event is a dense core, which, if massive enough, becomes a black hole, a singularity wrapped in an event horizon. Recently, for the first time in history, scientists have managed to peer closer to the core of a supermassive black hole than ever before. This black hole, located at the center of a galaxy an astonishing 800 million light-years away, revealed something extraordinary. Typically, black holes feast on anything that ventures too close, devouring matter like cosmic monsters. But what scientists observed defied all expectations. As matter spiraled into this black hole, it was superheated to temperatures of millions of degrees, forming a glowing ring of gas and energy called a corona around the black hole. This corona generated intense X-ray flares, bursts of high-energy light that lit up like fireworks near the abyss. But then came the shocking twist. Some of these flares didn't vanish into the black hole's maw. Instead, they appeared to bounce, reflecting from gas behind the black hole itself. How could this be? How could light seemingly survive a place where physics tells us nothing can escape? The explanation lies in the black hole's colossal gravitational and magnetic fields. These forces are so extreme that they can bend and twist light itself, forcing photons to take curved paths around the black hole before escaping outward. This phenomenon marks the first ever direct observation of light coming from inside the region so close to a black hole's event horizon. The discovery confirmed one of Einstein's boldest predictions, that gravity can bend light. Over a century ago, Einstein suggested this idea in his general theory of relativity, and now, modern telescopes have provided stunning visual evidence of it happening near one of the universe's most powerful gravitational wells. But how did astronomers capture this extraordinary spectacle? It all began with two cutting-edge space telescopes, the European Space Agency's XMM Newton, and NASA's New Star, Nuclear Spectroscopic Telescope Array. These telescopes were focused on the supermassive black hole, recording data over several days. The scientists observed powerful X-ray flares emanating from the scorching corona around the black hole. However, upon deeper analysis, they noticed something unusual. Some of the flares had shifted colors and arrived later than others. Why were they delayed? And why did they appear different from the direct emissions? The answer, as it turned out, lay in an extraordinary cosmic ballet. These late-arriving X-rays were light echoes, reflected flares that had been bent and warped by the immense gravity around the black hole before traveling to the telescopes. The discovery provided a direct glimpse into the warped space-time near the black hole, revealing a chaotic and surreal environment where light follows mind-bending paths. In the swirling chaos around a black hole, gas and dust are heated to extreme levels, forming a spinning disk called an accretion disk. The material glows intensely as it spirals inward, emitting X-rays and other high-energy radiation. The corona, a halo of superheated gas, floats above this disk, producing the violent flares that we observed. This discovery is monumental, not just for confirming Einstein's predictions, but for providing an unprecedented window into the most extreme environments in the universe. It brings us one step closer to answering the age-old questions: what happens inside a black hole? Could they be the key to unlocking deeper mysteries of space, time, and reality itself? What do you think about this fascinating cosmic revelation? Could the secrets of black holes hold the answers to the nature of the universe? Let us know your thoughts in the comments section below. If you enjoyed this video and want more mind-blowing discoveries from the depths of space, be sure to like, subscribe to Waves Discovery, and turn on notifications so you never miss a new episode. Thanks for watching, and we'll see you next time as we journey deeper into the mysteries of the cosmos.